Today, we will be doing an overview of the NCBI gene database. To start off, I will show you how to do some preliminary research on a gene of interest. It's always a good idea to do some preliminary research on a gene that you're going to be studying. And to do this, I've just pulled up my browser and typed in the organism name and the gene that I'm looking for. And after doing a quick search, I see some websites that pop up. Two that I want to point you out are UniProt and Flybase, and these are going to be good resources for gathering information. So some things that you want to look for in these websites are particularly what the gene does. Here we can see GAPDH is involved in glycolysis and does some other things as well, but you want to take note of that. Also, you want to copy down to your notes any aliases that the gene might have or symbols associated. That way, if it pops up under a different name, you'll still be able to recognize it. Now that we know a bit about the gene that we're working with, we can get started searching for it in NCBI. To navigate to the NCBI website, all you need to do is type it into your search engine, and it should be the first result that pops up. I would recommend that you bookmark this page, as you will be referring to it quite a bit. So, now that we're here, what is NCBI? That stands for the National Center of Biotechnology Information. It houses a series of databases, and particularly of interest are the searchable genomes of a variety of organisms that have been sequenced. And we will be using these sequences in annotation. So, how do we search for a target gene of interest? Since we know the name of our gene from our preliminary research, all we have to do is paste that into the search bar and hit enter. And of note is that I'm using the abbreviated form of the name. However, typing in glyceraldehyde 3-phosphate would be just as adequate. And also of note is that you don't have to get the spelling to be perfect. If you mess up a little bit, it'll account for it and still pull up some search results. And once we're here, you'll see the gene and the protein tab, but we're going to navigate to the gene tab. Of note, there are many search results that popped up, and in many different organisms. Here we can see humans. So if we want to narrow down the search results, all we have to do is click Advanced Search, and this will pop up. Once in the Advanced Search Builder, you're going to have to re-enter the gene, and then go to this drop-down menu and select Organism. Then type in the name of the organism we're looking for. Here is a drop-down menu that you can select, and you're going to want to look for your organism. Here we do not have melanogaster pop up, so we need to give them more information. Note that it does not refresh automatically. You have to hide and then re-show the index list. And after doing so, we get successfully Drosophila melanogaster with an ID number next to it. It's very important that you select this ID number, or else the search will not go off successfully. After seeing the form field change, we can go ahead and hit search. After doing the advanced search, we only get 3 results rather than the 1,000 plus that we had from before. And I'm going to go ahead and select the first result, which brings us to the gene page for GAPDH in melanogaster. Having successfully navigated here, I will be doing an overview of what the NCBI gene page has to offer. Here on the gene page, you want to take note of this table of contents off to the right, and these are not hyperlinks that lead to external parts of the site, but rather they are a way to quickly navigate within this site. Take note of the reference sequences, or RefSeq here, as they are a collection of publicly available DNA, RNA, or protein sequences that are the consensus for a given organism. And clicking that will shoot us down the page to here, and here we have the DNA, RNA, protein. Here is the NM accession number for the mRNA with the M, and the NP for the protein. In order to navigate to the protein page, you want to click the protein accession number, though it is recommended when doing this to open it in a new tab, just in case you need to refer back to the gene page in the future. So now I will quickly go over the target protein page and the different features there. So here on the protein page, there's a lot of good information. You want to take down and remember the accession number and the amino acid length for the protein in question, as well as these hyperlinks off to the side. Here you're going to see run blast and identify conserved domains, and there is also the link to the FASTA sequence. So out of all of these, the run blast will be covered in the next video in the series, but for now, let's go ahead and talk about the conserved domains. Here is a graphical depiction of the protein domain, and you're going to want to put this into your notes as it is a valuable tool when making comparisons to the Asian citrus psyllid going forward. But for now, after you've copied it over, go ahead and backtrack and select the FASTA sequence. FASTA is a text-based code that represents the nucleotide or amino acid sequences using single letter codes. The format starts off with a caret, followed by the accession number and any other sequence names or identifiers. The sequence then begins on the next line, and for us, since we're examining proteins, this is the amino acid sequence. So go ahead and copy this into your notes, as FASTA is a fairly universal format in bioinformatics, so it'll be used a lot in a lot of different databases. Last, I just want to provide some example notes to show different things that I would be taking down during this process. Here, I took down the gene name and function from UniProt, as well as any aliases from Flybase, and definitely don't worry about manually typing any of this in. I just took screenshots and pasted them in. But from the NCBI protein page, I went ahead and copied all this in, just to have the name, isoform, and accession number and amino acid sequence. Additionally, I copied down the conserved domains, just to use for future reference, and the FASTA sequence in text form. That way I can easily search in the future. So that has been all for this video. Happy annotating!